Hello everyone, I am from Sri Venkateshwara College of Engineering. Name Rekha M. Branch Electronics and Communication in Engineering. Subject Electronics Principle and Circuits. Today I am going to explain about the topic of how does loading effect impact the input impedance of a circuit and give a equation for input voltage. Draw the CE amplifier. First circuit, next AC equivalent circuit, next effect of input impedance. Introduction to CE amplifiers. CE amplifiers are widely used in analog electronics for signal amplification. Understanding the loading effect is crucial for optimizing amplifier performance. This presentation will explore the impact of loading on impedance and input voltage draw. Impedance in CE amplifiers. Impedance is the measure of how much is circuit resists the flow of alternating current. In a CE amplifier, input and output impedances play a crucial role in signal integrity. High input impedance is designed to minimize loading on the proceeding stage. The loading effect of input impedance. We assume an ideal AC voltage source with zero sources resistance, but practically it has some resistance. This resistance reduces the AC voltage appearing across the emitter diode. This is known as the loading effect of input impedance of an AC source. What is the loading effect? The loading effect refers to the impact of connecting a load on a circuit's performance. It can cause significant changes in voltage and current, affecting overall gain. Analyzing loading effects helps in designing circuits with better stability and accuracy. Loading effects. The output of a sensor device may devise from the current value due to loading effect. We can organize two types of loading effect: inter-element loading and process loading. Inter-element loading means a given element in the system may modify the characteristics of the previous element. Process loading means the introduction of the sensing element into the process or system being measured causes the value of the measured variable to change. Impact of loading on impedance. Loading can reduce the effective input impedance of an amplifier. Lower impedance can lead to increased current draw and diminished signal quality. It is essential to consider loading effects when designing for specific amplification applications. Input impedance. The AC voltage source VG has an internal resistance of RG. When the alternating current generator is not stiff, some of the alternating current source voltage is dropped across its internal resistance. The alternating current voltage between the base and ground is less than ideal. The alternating current generator has to drive the input impedance of the stage Z in stage. The input impedance include the effects of the biasing resistors. R1 and R2 is parallel with input impedance of the base Z in base. The input impedance of the stage equals to Z in stage equals R1 parallel with R2 parallel with beta Re dash. Input voltage draw in CE amplifiers. The input voltage draw is influenced by the input impedance of the CE amplifier. A lower input impedance results in a higher current draw from the source. Understanding the relationship is vital for achieving desired performance levels. This is the diagram of CE amplifier. Equation for input voltage. When the generator is not stiff, the AC input voltage V in ID less than Vg with the voltage divider theorem. V in equals Z in stage divided by Rg plus Z in stage into Vg. The generator is stiff when Rg is less than 0.01 Z in stage. Equation for input voltage draw. The input voltage draw can be calculated using Ohm's law. V equals I into R. In a CE amplifier, the input voltage Vin minus derived from the source voltage Vs minus the voltage drop across the input impedance. This equation helps in performing how loading affects the input voltage. Example calculations of input voltage draw. Consider a CE amplifier with an input impedance of 10 kilo ohm. If the source voltage is 5 volt and the current draw is zero point 0.5 milliampere, the voltage drop is 5 volt. Zero point 0.5 milliampere into 10 kilo ohm. This results is in an input voltage draw that can significantly change the expected output. Mitigating loading effects. Techniques such as buffering can help maintain high impedance and produce loading. Using high impedance sources can minimize the impact of loading on amplifier performance. Careful circuit design is essential for maintaining the integrity of the signal. Practical applications. Understanding loading effects is crucial in audio, radio frequency, and sensor circuits. Designers must account for loading when integrating multiple stages or complements. Properly addressing loading issues improves overall circuit stability and performance. Conclusion and key takeaways. The loading effect significantly impacts impedance and input voltage draw in CE amplifiers. Recognizing and calculating these effects is essential for effective circuit design. By, by employing strategies to mitigate loading, designers can enhance amplifier performance. This presentation provides a comprehensive overview of the loading circuit and its implications on CE amplifiers. Thank you everyone watching my channel. Please like, share and subscribe the channel. Thank you everyone.